We're here with the Tektronix 2247A model oscilloscope, and when I first got this scope, it wasn't getting any output on the screen, but it booted up fine. The panel was properly lit. It displayed no error codes, so I figured I'd have to take a look at the power supply. So I've gone ahead and taken the top off, and I've properly discharged the CRT anode. And I've used a multimeter and checked all the caps before I started lifting up the board to pull it out so I could take a look at it. And you won't believe what I found. So let me set this down and pull out the power supply board and show you. Bear with me for a minute here. Alright, let's go ahead and take this out. So, now there are two heat sinks that the service manual recommends grabbing onto to successfully pull out the power supply, and it works like a charm, except just gotta get past everything. There's one of those darn wire guides in the way. There we go. Just grab a hold of this. Slide right out. Alright. There you have it. So, if you could see here, here's the power supply. Now, upon examining it, I took a look at this, let's see here, this capacitor over here. I don't know if you can see it on the camera. It's 0.01 MFD, 4,000 volt cap, and it's hooked up to the high voltage CRT circuitry. Now, I noticed underneath this, it's axial lead, so it's got this top terminal coming off here, and this is the ground terminal, and it's supposed to go to ground. But I noticed, it's hard to see, but there's a trace here, and it looks like, I don't know if it's a manufacturing defect or if they purposely made the trace go very tiny, then widen back out. It sort of tapers over by this screw hole here. But if you look even closer in the light, it's actually an open circuit. So I've gone ahead online and grabbed the schematic for the power supply, and I've located this cap. It happens to be a capacitor 2244, and it's supposed to go through a 100 ohm resistor to ground. Well, it doesn't do that. It was opened. So I've gone ahead and patched in a prototyping wire there from that negative lead to that 100 ohm resistor, which then goes to ground. There's this 100 ohm resistor here, and that's what's on the schematic, and I checked it, and the resistance is perfect. 104 ohms it actually read. So we'll go ahead and put the scope back together and see what we got. There's one thing I have to stress with working with this, with power supply circuits, especially CRT circuitries. Be careful of the high voltage circuitry. Turn your back once, it'll get you. So make sure you discharge it. Discharge it straight to the chassis, and that's what the manual called for, and that's what I did. It had been sitting for a little while, so it actually didn't spark, or nothing exciting happened. There we go. And route the anode lead and the high voltage. Now look at this. I don't know if you can see. These are the 3 wires that supply the high voltage to the back of the CRT. Interesting. But anyway, we'll go ahead and connect that down to the jumper. That's what it's labeled there on the board. So, even I know no voltage exists on this board, I'm still nervous getting my fingers near all these capacitors. So, alright, I'll plug the mains port in. And the fan circuit. The nice thing about this this scope is that it's 100% made in the USA. See on the power supply board here, it says Tektronix 1986, made in the USA. You don't see that today very often with power supplies. It's usually made in China, along with most consumer electronics. I'll go ahead and screw down the 6 screws that hold it in place. They're Tektronix T10 screws. So if you ever have a scope, old tech CRT scope, and you want to get down in it, you'll need a Tektronix T15. So be sure to keep that handy. There we go. It's actually very serviceable, service-friendly. Take off the top cover. It takes 5 screws to get that top cover off. Slides right off. And take the processor board off, and then the power supply shield, and you're good to go. So let's take a look at it here. So it's secured in there, so I'm going to go ahead and get this shield on here. It's over here. Let's see. Caution. Do not remove this shield while line cord is connected to power. AC line potential and CRT circuit high voltage present under this shield. So there's your warning in case it's not clear enough. Okay. It's plugged in. Perfect. Almost forgot. These old scopes use these rods that connect from the front control panel all the way to the back, and they have one rod for the power switch going all the way to the back, toward the back of the CRT here. If you can see, here's the button, and it goes all the way back here, and there's a joint where this rod will then connect at 90 degrees to this green switch there. So go ahead and connect this. I remember how it goes. It should be just like that. Okay. Alright. Yep. Like a charm. It drops right in like that. Sort of a pain. Gotta wiggle this darn thing in. Come on. Ah. God. There we go. Beautiful. Alright, now pop this back down here. Now we can put the shield on. Remember how this goes correctly, just like this. She'll sit in there. Awesome. She a charm. Okay. If you notice, when you put the shield on, it doesn't seat by itself, and that's because it's got these nice springs right here to ensure proper grounding. So it's a nice design there. Okay. Now this is the tedious part, doing all this with the screws, but okay, 2 more for the shield. Ribbon cables are everywhere, and I got those pins riveted to the end of them. If you hit them the right way with your hand, it doesn't feel too good. Okay, so we have the shield in here. It's all screwed down. Now we have the processor board to work with. Now, keep in mind when handling it, you'll want to ground yourself with a wrist strap. So, just so you don't risk damaging any of the components. So, follow proper ESD caution. And my meter turned off. Okay. Alright, connect the anode lead first. Alright, okay. And let's see here. This would have went like this. Beautiful. And here comes the fun part. All these connectors, there's 1, 2, 3, 4, 5, 6, 6 ribbon cables, and where in the world did that one cable go? Well, I must have closed it down on the EMI shield. But it's not really a cable, it's like a little jumper. Yep. Come on. Get out. Thank you. Alright. If you're wondering what cable I was talking about, this little black one here was stuck underneath the shield, and I had screwed the shield down on top of it, so change the camera for a better view here. Oh, let's see. That should be okay. Alright, let's put this in. Okay. Boy, I'm surprised I haven't broken any of these off. It's fairly common in older computer systems and electronics. K-Pro was full of them when I was getting that fixed up. That's all working now. That was full of them, and so was that over there, old IBM AT. So plug that little jumper cable in, and 2 more ribbon cables. Let's one down, one left. Alright. Well, let's go ahead and screw it in. So the processor board has two long screws, and they'll go in the center here. And there's four shorter ones, and one will go at each corner. There, one here, and two more. So, I don't want to torque the board down too tight because the screw head does directly go on the board, so make sure you have the proper torque on them. You could do it by hand, but the service manual does actually give you a torque setting. I can't recall what they said, but if you've taken electronics apart many times, you know what torque to do, so there's no need to be all specific about it. Okay, ribbon cables are all connected, and well, let's go ahead and put the case in. Well, I could test it as is, but screw it. Yep. All right. Beautiful. Oops. That'd be a knob that came off. Easily fixed. Just pull the darn thing off again. Let's see. The intensity, one of the intensity knobs came off, and here it is. So, yep, there it is. Beauty. Okay. Looks like we're in. Yeah, okay. A little pocket thing on. Hold your probes and manual, whatever you use it for. And this back plate here. Yeah. Now, we need to push it in more. I'm just going to attach it this way. There's 4 machine screws that go in the back here to hold it in place. So. Alright, one last screw, some sort of security screw there. Goes on the side here, really doesn't have much of a purpose. There you have it. And power cable for mains, so here we go. Alright, assembled. It's about time, huh? Alright, now, nothing fancy to the back here. Have your counter timer input and your Z-axis input. Fuses right here, so. Oh, let's plug it in. Turn it on. Put down our handy dandy handle. There we go. Right. Alright. Well, it appears to be working. I don't know if you can see it on there. I don't have a function generator, unfortunately, to test the darn thing out. You know, a nice sine wave in there. Yep. There you have it. Illuminating scale. These are your intensities knobs. Focus. Focus works nice. That's about right. Well, it works. Beautiful. And there's an old Macintosh Classic. That didn't boot up. I had to take the power supply out of this one and replace all the caps on it. I think I have some old left in here. Yep, here's a couple ones I still had. These old ones from, it's a Nichicon 2200 micro 16 volt ones. There's a bunch of them, and they have that nice fish odor to them.